So the next concept is of the speed and the velocity. Is it clear? So we are going to discuss the speed first. Is it clear? So what is the speed? Listen one thing. Suppose the initial position is of the point is of the particle is at A at time t1. The particle is A. It moves like this and reaches to the point B, right? Traveling, covering this displacement and reaches to the point B at time t2. So what is the total time travel? Total time travel. Can you tell? Total time taken is how much? You will say t2 minus t1. Is it clear or not, you tell? And what is the total distance? Total distance. Total distance is nothing but path length AB. Path length AB. Is it clear or not? Listen one thing. The speed. I'm writing in short, not giving you the definition in English language. Only I'm explaining this. The speed may be defined in the two ways. First, the average. Second, the instantaneous. You understand or not? So first I'm explaining the average speed. All right. The average speed is defined as the total distance covered divided by total time. That's it. So the average speed is nothing but total distance. What is the total distance? Total distance is nothing but till s. And what is the total time? Say t, or this may be written as the t. Is it clear or not? So the average speed, the total distance divided by total time during the motion is called the average speed, and it is a scalar quantity, right? And the SI unit is what? You will say is meter per second. Is it clear or not, Yuta? For example, if you consider the odometer, right? Speedometer, you can say, right? Next is instantaneous speed. If you consider the speedometer of your scooty or your car, right? Sometime when you are driving your scooty or you are running your car, right? Sometime the car speed is 10 kilometer shown by the meter, 10 kilometer per hour. Sometime it become 20 kilometer per hour. When the red signal comes, the speed becomes 0. Are you getting or not? So the instantaneous speed is nothing but the speed at a particular instant of that time. You understand or not? But what is the average? The average speed, how much distance you are covered and how much total time you have taken is called the average speed. And what about the instantaneous speed? Speed at particular instant of time is called instantaneous speed. All right, this is the speed, right? So this is all about speed, and then I will explain the velocity, right? Copy this first. In the same figure, we are going to discuss the velocity, right? The velocity is a vector quantity, and again the velocity is of two types, the average velocity and the instantaneous velocity, right? How to find the velocity? First, I will explain the average velocity. Average velocity. V average, it is a vector quantity. Listen one thing. If this is the initial position, right? This is the final position, right? This is the displacement vector. Fine. So what the average velocity is defined as, right? Total displacement divided by total time. What is the total displacement? The total displacement is nothing but the AB vector. And what is the total time? Total time is nothing but T2 minus T1. The total time is T2 minus T1, and the total displacement is nothing but R2 minus R1. Is it clear or not, you tell? So delta R upon delta T can we write like this? This is the average velocity. Fine. Total displacement divided by total time is defined as the average velocity. It is a vector quantity. Vector quantity. SI unit is again meter per second. Is it clear or not, you tell? What about the instantaneous velocity? The instantaneous velocity is defined by Vt, right? The velocity at the instantaneous velocity Vt is defined as velocity of particle or an object at a particular instant of time. Listen, mathematically also we can define particular time velocity. What is the difference between the instantaneous speed and the instantaneous velocity? For example, here the instantaneous speed is what? Say 20 km per hour. At this point, the instantaneous speed is what? Say 10 km per hour. But if you writing the instantaneous velocity together with its magnitude, you have to give the direction also. Is it clear or not? 20 km per hour is the magnitude, and some direction will be there in east, west, north, south, like that. So that is the thing. Mathematically, how do we define the instantaneous velocity? Listen one thing. The delta R upon delta T. Delta R upon delta T. For example, this you can assume it is to be delta R. Delta R or simple R, you can write, both are the correct thing. Is it clear or not? Delta R is the finite change, right? Finite change. And listen one thing. For example, R2 minus R1, right? If there is a very small change, delta R tending to 0. If delta R tending to 0, then delta R become dr. You understand or not? And in the same way, the delta T become dt. If delta T tending to 0, it means, what is the delta T? For example, in the average here, try to understand, it is very important. When you are taking the average, T2 minus T1, R2 minus R1, in the average case, T2 will be suppose the 5 second, T1 initially is suppose the 2 second, and T2 will be the 5 second. There will be the big difference in the time. Is it clear or not? But when you are defining the instantaneous velocity, T1 is suppose 2.0 second. Here, suppose the T1, and the T2 is just near to this time, 0.1 second. That is, the two instants are very close to each other. Here, suppose this is the T1, right, the 2 second, and it is the 5 second. Are you getting? So between the 2 second and the 5 second, the time difference is very much. Then we have to find the average. But for the instantaneous case, if you want to find the instantaneous velocity or instantaneous acceleration like that, the T1 and T2 are very close to each other. That is, at this instant, just after microsecond or the millisecond, right, the T2 time occurs. So therefore, if you want to find the change in time, here the change in time is what? Say 3 seconds it will come. 5 minus 2 is equal to 3. But here for the instantaneous case, 2.0001 minus 2.0000. So what will you get? 0.00001 second, 10 ki power minus 5 second. So delta t is what? The delta t time is very small. When the delta t time is very small, it is tending to 0, right? It is tending to 0. Therefore, the delta t become dt. This is the mathematically way to represent the elemental change. This is the finite change. If delta t is the 3 second, it is the finite change, very big change. But if delta t is very small, it is the elemental change, and in that case delta t is defined as dt. Is it clear or not? For the instantaneous velocity, the change in time is very small, very elemental change. So therefore we will write limit delta t tending to 0. Then if delta t tending to 0, the delta t represented by dt, and also the delta r become dr. So this is defined as the instantaneous speed. So the instantaneous speed is nothing but dr upon dt. This is the mathematically definition for the instantaneous velocity or the speed. Is it clear or not? Although you may write the definition when we will do the question, then you can better understand, right? So read this question. In this question, a particle travel the first half distance. Suppose this is the total distance, total path length is AB. This is the first half distance, right? And this is the rest half distance. From here to here, the speed is v1. Then in the remaining half, the speed of the particle is v2. Find the average speed. The average speed you have to find. Average speed is defined as the total distance divided by total time. Listen, the speed is different, so the time t1 and the t2 will also be the different. Is it clear or not, you tell? So total distance is what? You will say the s, the total time is t1 plus t2. All right. For the first half, listen one thing. S is equal to ut. You understand this thing? The distance is equal to speed into time. So what is the distance? For the first half, I am assuming it is the AO. For the AO, right? The distance is what? Say s by 2. The speed is say v1. The time is say t1. So what is the t1? S upon 2v1. Is it clear or not, you tell? So this is the time taken from A to O. What is the time taken from O to B? The distance is, I will apply this. Distance is equal to speed into time. Are you getting this thing or not? The T2 is what? S upon 2v2. So this is T1 and T2. So I will put over here the S upon, right? What is the T1? S upon 2v1, S upon 2v2. Is it clear or not? So it is cancelled, 2v1 plus 2v2. If you simplify, if you take the 2 common, 1 upon v1 plus 1 upon v2, right? This 2 goes in the numerator. And what about this? v1, v2 is the LCM, v2 plus v1, right? And it goes 2v1, v2 upon v1 plus v2. So the average speed is what? 2v1, v2 upon v1 plus v2. If half of the path is covered by speed v1, the remaining half of the part is covered by v2, right? Although in the very first time the student think the average speed will be v1 plus v2 by 2, which is wrong. Are you getting? We have to find the definition, by the definition, total distance divided by total time. The T1 is different, T2 is different. Find the T1 and T2 separately, put the value, you will get the average velocity or the average speed. And this formula you have to remember to find the direct answer, right? Copy this. Read this question. in this question, a particle travel with the speed v1 for the first half time interval. Suppose this is the A, O and B. First half of the time interval mean the total time assumed to be the t. So the first half of the time interval is what? T by 2. The second half time interval is what? T by 2. For the half time, it covers with the speed v1. For the remaining half of the time period, it covers with the speed v2. This is different from the previous one. In the previous case, the half distance was covered by the v1, the remaining half was covered with the v2. Here, the half time period, the v1 speed. This is the timing is same. Listen, timing is same for the two half, but the speed is different. Therefore, the distance s1 and the distance s2 will be the different or not, you tell. Right? So what is the average velocity? Average velocity is nothing but total displacement divided by total time. What is the total displacement, Vinda? S1 plus S2. Is it clear? What is the total time? Say T by 2 plus T by 2. Is it clear or not, you tell? Right. Now, from O to A to O, S is equal to UT you will apply. What is the distance? You will say S1. What is the speed? V1. What is the time? Say T by 2. You understand this? What about O to B? Again S is equal to UT. What is the distance? S2. What is the speed? Say V2. The time is T2. So this is S1 and this is the S2. What is the S1? You tell. V1 into T by 2. What is the S2? Say V2 into T by 2. Is it clear or not, Vinda? So from here, the T by 2 is common. V1 plus V2 divided by T. This T is cancelled out. So V1 plus V2 by 2. So this is the average velocity or the average speed also you can say in this case, because the particle is moving in a straight line, right? When the half time period it cover V1, for remaining half time period is covered with the speed V2, then the average velocity comes to be V1 plus V2 by 2. All right, copy this. So read this question. In this question, a car moves with velocity in first minute. This is the first minute, and the velocity of the car is V1 is equal to 2.24 kilometer per hour. Right. In the second minute, what is the velocity? For the second minute, the velocity is 3.6 kilometer per hour. All right. And on the third minute, what is the velocity? It is 5.18 kilometer per hour. Is it clear? This is the time. T1 is equal to 1 minute, right? 1 minute, and it is also equal to the 1 minute. But since the velocities are different, so the distance will be S1, S2, S3. The distance will be the different, right? So S is equal to UT. Distance is equal to speed into time. So the average velocity we have to find the total displacement. What is the total displacement from point A to B to C to D, right? A, B, C to D, you can write S1 plus S2 plus S3, time is T1 plus T2 plus T3, right? What will you write the S1? The S1 is V1 into T, right? T is equal to 1 minute mean 1 upon 16 hour, right? So V1 is what? 2.24 is the kilometer per hour into 1 by 60. So when you will calculate this, this is the S1. In the same way, the S2, the S3 can be written as, right? So what is the S1 I am writing here? S1 is V1 into time is 1 upon 60 plus, right? What is the S2? S2 is V2 into T2, right? So 3.6 into T2. What is the S3? S3 is V3 into T. So V3 is 5.18 into 1 by 60. And what is the time? Is 1 by 60 plus 1 by 60 plus 1 by 60. Right. So the average velocity will be in kilometer per hour. So how would you calculate this? 1 by 60 if you take common, right? So 2.24 plus 3.6, 5.18, and this is how much? The total time is 3 into 1 by 60. It is cancel out. So the speed will be 2.24, right? 3.6 plus 5.18 divided by 3. 2.24, 3.6, 5.18, 8 और 4 12, 4 और 2 9 जीरो, यहाँ से लग गया 1, 5 10 11, 11 अपॉन 11.02 अपॉन 3, एंड दिस इज 3 3 9, 3 6 18 और 3 7 21, 3.67 kilometer per hour approximately the average velocity is in this case. Is it clear or not? So we are using the formula for the average velocity, total displacement divided by total time. Here the S2 distance will be calculated, S3 will be calculated in this way, right? Copy this. Yes. Actually, listen one thing. This is kilometer per hour, right? The speed is 2.24 kilometer per hour, right? This is the V, and the time is given as the 1 minute. So you have to convert into R. So R can be cancelled out, right? This is the 1 minute. You understand, in 1 minute, right? And in 60 minute is equal to what? Say 1 hour. Therefore 1 minute is equal to what? 1 by 60 hour. So I have converted the minute into hour, so that the distance can become into kilometer. So this is the distance S1 written in kilometer. In the same way, this is the distance written in kilometer and kilometer. Is it clear or not? And this is written R. So the unit of the average velocity will be kilometer per hour. So that is why it is written as kilometer per hour is the unit of the average velocity, right? Copy this. So read this question. In this question, a bird flies due north. Suppose this is the east, west, north and south, right? Starting point is this, towards north, right? And suppose this is the north and reach from O to A. And what is the velocity? Say velocity is 20 meter per second and the time is 15 seconds, right? This is the time from O to A. Then flies due south. Okay, due south means it move back, first north then south. You understand or not? With velocity how much? Then it move, this is the 20 meter per second, then it move due south with speed 24 meter per second, right? Actually this is the point. Listen one thing, on the same line, first start from here going like this and then turn back, right? Suppose this is the point A, right? Turn back in the same direction. Initially it is going like this, then turn back in this direction. For how much time you tell? For 10 seconds. So it is moving in this way with the 24 meter per second in 10 seconds. Time T2 is 10 seconds. Listen one thing, if this is the point, first you find the S1. What is the S1? Say S is equal to VT, UT. So U is what? Say 20. And how much time? Say 15. Say 300 meter. So distance covered in this direction is 300 meter in 15 seconds, right? Then S2 is equal to what? UT again. The speed is what? 24. And what is the time? Say 10. So 240 meter is the distance covered in the backward direction. So first it move for the 300 meter towards north, Is it clear? Then it turn back, and what the distance is covered by the bird? This is 240 meter. You understand or not? You tell. And what is the total time? Total time is 15 plus 10 second. So initially from O to A, then A to B. So this is the final position. So to find the average speed, what is the formula for average speed? You will say total distance divided by total time. What is the total path length, Vrinda? 300 plus 240. 300 plus 4. And what is the total time taken? 15 plus 10. Right. So this is, oh, it is at rest also. Oh, sorry. It rest for 5 seconds. Listen one thing. It is rest for, this is the time, extra time, 5 seconds also. So you have to take the total time only. Right. Total distance is this much and total time is 15 plus 5 plus 10. Okay, 5 seconds is also taken. So how much is this? Is 30, right? So this is how much? 18 meter per second. Are you getting or not? This is the average speed. And if we found the average velocity is nothing but total displacement, right, divided by total time, right? Can you tell me what is the total time, total displacement? The line joining initial, yes, this is the displacement, 60 meter, right, towards north. So displacement is 60. And what is the total time? 15 plus 5 plus, yes, 30. So this is 2 meter per second. And the velocity is a vector quantity, right? Although it is only the asking the magnitude. So this is the velocity, 2 meter per second. And what is the direction? Say towards north, you can say, right? And this is the speed. This is the average velocity. You understand the difference between the average speed and the average velocity. Also, the important thing is that if it is at rest somewhere during the journey, this time is also be taken, because we have to write here the total time. Understood? Copy this. So before doing the next question, some concept I'm asking you, I'm telling you the differentiation. You understand the differentiation? Tell me. Yes. If t square, x is equal to t square, can you tell me what is the differentiation of t square? 2t, right. And what about the t? Dx upon dt is equal to 1. And x is equal to constant, then dx upon dt is equal to, say, 0. Right. I think you know this. Right. So no need to write this if you know. Right. Okay, listen one thing. So read this question. In this question, the displacement of the particle along a straight line is given by is equal to 4t square plus 5t minus 6. Here s is in centimeter and t is second. Calculate the initial speed. So initial speed and the speed at 4 seconds you have to find. Whenever the s as a function of time t is given and you want to find the instantaneous speed or the instantaneous velocity, the instantaneous velocity is nothing but the differentiation of the position with respect to time. So if ds upon dt, what is the differentiation of t square? You said 2t. This is 1, this is 0. So this is the velocity as a function of time t. You understand or not? This is the instantaneous velocity. Instantaneous velocity or instantaneous speed, you can say, if this is the distance. Fine. So first part, initial speed mean at what time? Say t is equal to 0. So initial speed is 5 meter per second. Second, the speed at 4 seconds. So v4. If you put the 4, 8 into 4 plus 5, 8 चौक 32 और 5, 37 meter per second. Oh, centimeter per second. Centimeter per second. Right, because this s is given in centimeter, right? Copy this. So read this question. The first part is, if s is equal to what? is equal to 2t cube plus 3t square, right, plus 2t plus 8. Then you have to find the time when the acceleration is 0. If the displacement is given, so the ds upon dt is what? Say velocity. If you differentiate this, 8t square plus 6t plus 2 plus 0. I think you understand. If the velocity as a function is known as a function of time t, then how to find the acceleration? When the again differentiate the velocity with respect to time, you will get the acceleration. So this is 8 to the 16, 16t plus 6 plus 0. So this is the acceleration with time t. And you will see this acceleration can never be 0 because time t is what? Time t is always greater than and equal to 0. Time is always positive. So when the acceleration will be 0, if acceleration is equal to 0, what will, yes, wait for 1 minute, 60, right, this is what, say 12t, this is 12t, this is 12t, right. So if it is 0, then minus 6 is equal to 12t, so t is equal to what, say minus 1 by 2. So this is not possible, right. What is not possible? The acceleration is always positive. It cannot be 0. Why? Because time is always greater than 0. So minimum time will be 0. So minimum acceleration will be 6. And the time is increasing, the acceleration is also increasing. So this is not possible when the displacement of the particle is given in such a way and its acceleration can never be 0 according to this relation, right? This is the first part. Copy this. So read this question. In this question, velocity of the particle at t is equal to 0 varies, velocity varies as a 4t, and you have to find the displacement between, right, 2 to 4 seconds. So velocity is 4t. The velocity is written as ds upon dt whenever you want to write. So ds upon dt is what? Say 4t, and ds is equal to 4t into dt. All right. If you integrate this, 4t dt, right, so the total displacement u will be found. So t1 is what? 2 seconds to t2 is equal to what? Say 4 seconds. So you have to integrate from t1 2 second to 4 second. If 4 comes to be out of the integration dt, 2 to 4, can you write the integration of t? Yes, t square by 2, and the limit varies from 0 to 4, and this is the s1 minus s, right, s1 from s1 to s2, s from s1 to s2 is equal to what? 2 t square 2 to 4. When you will put the upper limit, this is the position s2 minus s1 is equal to 2 what? 4 square minus 2 square. Then you will s2 minus s1, final position minus initial position is nothing but the displacement, right, is nothing but s2 minus s1 is equal to 2 into 16 minus 4 is equal to how much? This is what? 12, 24 meter. So 24 meter is the displacement of this particle, right? Copy this. So read this question. In this question, air distance between Kota to Jaipur. This is the Kota and this is the, suppose, the Jaipur, right? Jaipur. And this distance, air to air distance is 260 kilometer. Fine. And when the road distance, definitely the road distance will be little longer, and this distance is 320 kilometer. Is it clear or not? Deluxe bus move from Jaipur to Kota takes, if this is the bus, it is moving along the road, how much time is taken? 8 hours. And while the aeroplane just reach, this is the, suppose, the aeroplane, right, this is the aeroplane, and it takes the time only 15 minutes. So first this minute will be converted into hour. So how to convert? Say 1 upon 60. So 1 upon hour, 1 upon 4 hour is the time taken. The first part, what is the first part? I'm writing the first part here. The first part is, what is the first part? The average speed of the bus. Tell me, starting point is this is the path length, and this is the final distillation. So what is the average speed? Can you tell? Total, yes, total distance divided by total time. So what is the distance? 320. And what is the time? Say 8 hours. So 40 kilometer per hour is the average speed of the bus. Fine. What is the second part? Average velocity of the bus. The average velocity. What will you write? The total displacement, right, divided by total time. When the bus is moving along this path, can you tell me what is the total displacement with the total displacement is what? Line joining initial to final position or the shortest distance. 260 divided by 8, 13 divided by 4, 65 divided by 2 is equal to 30, right? 2.5 kilometer per hour. So this is the average velocity. Now, what about the third part? Now for the aeroplane, the average speed of the aeroplane. Average speed is nothing but distance divided by time. The distance divided by time. When the aeroplane is moving, listen, what is the distance covered? The distance covered is what? Say 260. And what is the time? Say 1 upon 4. Here the minute is converted into hour. So therefore 260 into 4, right, 4 6 24, 4 दूनी 8 और 2 10 kilometer per hour. Is it clear or not? What about the average velocity? You tell. The average velocity is nothing but total displacement divided by total time. Listen, when the aeroplane is moving in a straight line, the distance and the displacement both are equal. You understand or not? So the displacement is again 260 and the time is again 14 and 1040 kilometer per hour will be the average velocity of the aeroplane. You understand this or not? Copy this. Listen. State when the aeroplane, listen, if this is the car or aeroplane, if it is moving in a straight line, for example, the aeroplane will also move. You have to assume that aeroplane is moving in a straight line because point to point distance is given, right? So whenever any particle is moving in a straight line, its distance and the displacement both are same. If direction is not reverse, you understand or not? It is moving forward in the same direction, in the same straight line. If particle is moving, its distance and its displacement both will be the same. So therefore the average speed and average velocity magnitude will be the same. You understand or not? Any other doubt, please tell. So read this question. The length of the minute hand of the clock is, suppose this is the clock, this is the minute hand, right, and the length is 4.5, right, centimeter. Fine. This is the tip of the minute hand, suppose this is the length 4.5 centimeter. Find the average velocity of the tip of the minute hand between 6 a.m. to 6:30 a.m. Listen one thing. This is 0, this is 3, this is 6. I think you understand 1, 2, 3, 4, 5 and 6. Yes, 8, 9, 10, 11 and this is the 12. So the minute hand, first part, when the minute 6 a.m., this is the 6 a.m. condition, the R end will be at this point. Are you getting? This is the 6 a.m. 6 a.m. And what about the 6:30 a.m. you tell? The minute end will be turn around, right, 180 degree, and this point will be reached to this point, and the R end will be like this. Some tilt will be there over here, right? So if you consider the minute hand, what is the total time in this case? First of all, tell me. 60 minutes. Oh, 30 minutes. Right? And what is the displacement? Because we have to find the average velocity. This is the initial, repeat. No, displacement. Yes, 2r, right. Because initially the particle is at this point, then move along the semicircle, reach to this from A to B. So this is the distance covered, and this is what? The line joining initial to final position. If this is r, this is r. So what is the displacement? The displacement is nothing but 2r is equal to 2 into 4.5, 9 centimeter. Is it clear or not? So what is the average velocity? Average velocity is nothing but total displacement, right, divided by total time. The displacement is 9 centimeter, time is 13 minutes, right? So 3 by 10, this is in centimeter, 3 by 10 centimeter per minute is the unit, right? And this is the average velocity from 6 a.m. to 6:30. 6 a.m. to 6:30 a.m. You understand or not, you tell? Right. So, and what about the second part, you tell? 6 a.m. Yes, displacement is same and the time will be the different, 6:30 p.m. So again, from here the displacement, you are correct. The displacement is what? 2r is equal to 9 centimeters. And what is the time? Can you tell? 6. Yes, 12.5 hours, right? And therefore the average velocity is nothing but total displacement divided by total time. So the unit will be 9 divided by 12.5 centimeter per hour is the average velocity for 6 a.m. to 6:30 p.m. Is it clear or not, you tell? Right, copy this. So read this question. In this question, particle of mass 2 kg moving in a circular path, right, with the constant speed 10 meter per second. Suppose 10 meter per second it start and it reaches to the, right, this point diametrically opposite, right, in half circle. It complete the half circle. You have to find what? Change in speed and the change in velocity. If this is the v1 velocity and this is the v2 vector velocity, suppose this is the x-axis, this is the y-axis, fine. The speed, speed is what? Say 10 meter per second. What is the speed? Say 10 meter per second. Only when the particle is moving in a circular path, only the direction is changing. So the velocity is changing, but the speed remains constant. So speed is constant. You understand or not? So what is therefore the change in speed? Change in speed, right? Speed is equal to 0. This is the first part. And now the change in velocity, how to find? Because if you assume this is the y-axis, this is the x-axis, the v1 velocity vector you can write 10 j cap because its direction is meter per second. And this is the velocity vector, you may write 10 minus 10 j cap. Is it clear or not? So what is the change in velocity? The change in velocity is nothing but v2 vector minus v1 vector. What is the v2 vector? Minus 10 j cap minus, what is the v1 vector? 10 j cap is equal to minus 20 j cap meter per second. So the change in velocity vector is nothing but minus 20 j cap meter per second. Although if you want to take its magnitude, right, the magnitude of the velocity is nothing but, what is the magnitude? Minus become plus, and the unit vector magnitude is what? 1. So it is 20 meter per second. So change in speed, no change in speed. Change in velocity, 20 meter per second. In how much time? In when it complete the half revolution. All right, copy this. So just I am solving. Read this question. Distance traveled by the particle is 2.5 t square. Average speed t is equal to 0 to 0.5 second. Sorry, 5 second you have to find. and the instantaneous. So listen one thing. First, the v you have to find ds upon dt is equal to 2.5 into 2t is equal to 5t. The instantaneous speed is 5t. All right, this is the one thing. Listen, a car, when the car is moving, the at t is equal to 0, can you find the speed is what? Say 0, right? And at t is equal to 0, the speed is 0, and at t is equal to 5 seconds. Can you tell me the speed at 5 seconds? Yes, 5 into 5 is equal to 25 meter per second. Is it clear or not, you tell? So the second part answer is what? The instantaneous speed at 5 seconds is 25 meter per second. This is the fine. Now listen one thing. At t is equal to 0, for the average time, the t1 is what? 0. When it is 0, so what is the s1? Say 0. And when t2 is become the 5 second, in 5 second, how much displacement is covered? Say 2.5 into 5 square. So this is 62.5 meter. Is it clear or not, you tell? Is it clear or not? This is the displacement function. T is equal to 0, the displacement is 0. Here, s is equal to 0. When it is moving, the velocity is increasing continuously. Velocity is increasing at 5 seconds. The velocity become 25, but the displacement, in this case, what is the displacement? S2 minus S1 is the displacement. This is the instantaneous velocity, the average velocity. Average velocity is always asked between the two time interval. Is it clear or not? So what is the time interval? Say t2 minus t1, s2 minus s1, or you can assume it delta s upon delta t. So what is the t2? Say 5 seconds. What is the t1? Say 0. At 5 seconds, yes, 62.5. What is the s1? Say 0. 62.5 upon 5 is the average velocity. 5 ekam 5 meter per second. This is the average velocity. So average velocity from 0 to 5 seconds is this. At 5 seconds, the instantaneous velocity is 25 meter per second. Right? Copy this. So read this question. In this question, particle goes from A to B. This is from A to B along the semicircle. The radius is R is equal to 1 meter. And the total time from A to B is what? 1 second. Is it clear? Find the magnitude of the average velocity. Average velocity is nothing but total displacement. What is the total displacement? Line joining initial to final position, say 2r. And what is the total time? Say t is the 1 second. So what is the radius? 1 upon 1. 2 meter per second is the average velocity. That's it. Copy this. So read this question. In this question, a straight distance between hotel, this is hotel, and the railway station is 10 kilometer. This is the distance. But circular route is followed by the taxi. This is the circular route. Taxi, this is 23 kilometer. And the time taken is what? Say 28 minutes. Fine. So what is the average speed? The average speed I am asking is nothing but total distance divided by total time. So what the distance you will write? Say 23 kilometer. Is it clear or not? And what is the time? So the time is 28 minutes. It will be converted into hour. Is it clear? 28 into 1 by 60 hour. So answer will be kilometer per hour, because taxi or car or the scooty or the motorcycle has the speed in kilometer per hour. So instead of the kilometer per minute, you have to write the unit in kilometer per hour, right? So this is 23 into 60 upon 28 kilometer per hour. When you will simplify, definitely you will get the answer. Is it clear or not, you tell? Right. What about the second part? The average velocity. Velocity average. What is the average velocity? Say displacement divided by time. Although this car is moving along this path like this, but this is the displacement only. So the displacement is 10 and the time is again, we have to take the time in r. This is the time. Is it clear or not? 28 into 1 by 60. So this is the 600 upon 28 kilometer per hour. So definitely the average speed and the average velocity are not equal. Is it clear? Right. Yes. Yeah. Okay. Repeat your question. Hmm. Listen. That is the thing. Try to understand. Suppose the particle or a car or the aeroplane is moving like this and here. Fine. Suppose it start at 2 p.m. and it reach to the 5 p.m. over here, and the particle is moving in this case. So now they will ask the average velocity and the average speed. So if you are finding the average speed, the time is nothing but 3 hours. Is it clear or not? But you may also ask the average velocity. Then this is the displacement, but the time is also equal to what? Say 3 hours. Total displacement divided by total time. Right? Car is not moving along this path. Car is moving along the circular turn. Right? So this is the distance and this is the displacement. So the average velocity, the time is, the distance is the shortest distance and the time is in which the car is moving along the circular path. So this time is not to be taken because the car is not moving along the path. Only this is the real situation. The hotel and the railway station are situated. Line to line distance is, point to point distance is 10 kilometer given. Right? But the total time it reaches. So average speed, this is the actual speed of the taxi. Understood? But this is the average velocity which is asking in the question. Total displacement and how much time it covers to reach the final position or the final destination. So the same time is to be taken. You understand or not? But yes, you are correct. Less time if the speed is same. But car is not moving along this path again, I am saying. Right? They ask the question in this way. Suppose aeroplane is moving here, the car is moving along this path. Right? So car is not moving in the straight line. If it is moving in this path, the total time is 3 hours. So the average speed you may write in the same way. Right? Average total distance upon total time. They also give the smallest distance or the line joining the initial final position. The displacement they give the displacement and then they will ask the average velocity. You understand or not? Car is not moving in this direction. If the car is moving along this direction, they will say there are the two roads. This is the one road, this is the another road. I am writing this question. This is the one road, the time is 2 hours. The another road, time is 1.5 hours. So they will ask if the car is, this is the path 1, this is the path 2. So if the car is moving along the path, then average